Okay, good morning all. Today we'll see about the next topic, that is basic relationship between the pixels. Okay, lastly in topic 2 we have discussed about sampling and quantization, how the image sampling and quantization has to be carried out. All that we had discussed, that is what are all the problems if proper sampling or not, and the different types of sampling, uniform sampling, non-uniform sampling, non-uniform quantization, all that we had discussed. But today we are going to discuss about the relationship between the pixels. This is very small topic too, but this one is very important. But this image processing, all the processing functions are going to be carried out with the operations taken place with the pixels. So if you want to apply some operator to the pixel, we have to know the relationship between the pixels. So we'll start now. So here first we are going to see about the neighbors of the pixel, later the connectivity between the pixels, then the connected components, how to label the connected components, and distance measures, logical arithmetic operations, all that we are going to discuss in this relationship between the pixels. So first we will see what is the neighbors of a pixel. We know neighbor means very next to us. So for example, you consider this X pixel, the neighbor is this O, okay, 1, 2, 3, 4, 4 neighbors. So that is N4 of P represents 4, number 4 represents, N represents number, 4 represents 4, okay, 4 means neighbors, 4 neighbors, that is the set of horizontal and vertical neighbors. So these, this one and this one represents horizontal neighbors, and this represents your vertical neighbors. And second thing is ND of P, that is diagonal neighbors, okay, diagonal pixels, number of diagonal neighbors. So okay, diagonally if a pixel is having this one diagonal neighbor, but this one is also very close to them, but it is not very near to them, it is connected in diagonal, so it is diagonal neighbor. This diagonal, here also 4 diagonal neighbors. A pixel will have 4 nearest neighbors and 4 diagonal neighbors. And N8 of P or 8 neighbors represents the unions of 4 neighbors and diagonal neighbors. So this 4 and this diagonal neighbors, totally 8 neighbors. A pixel is having 8 neighbors. So if it is diagonal neighbor, otherwise nearest neighbor. Okay. So that is the same thing I am showing here. X plus 1 y, x minus 1 y. This one coordinates. So if a pixel is here, this one is x plus 1 y. Here itself we can see. So if it is a pixel, this one is x plus 1, the same y axis here. Okay, x plus 1 y, x minus 1 y. This is x comma y plus 1. Here same x axis. So this one is y plus 1, this one is y minus 1. So this one is diagonal neighbors, how they are represented. So this level, this one is x comma y. So and above this level is x plus 1, y plus 1. Here this point is x plus 1, y plus 1. Here x axis and y axis this way. Okay, this point is x plus 1 point. So here x plus 1 and y plus 1. And this point, if you go back, this one is x minus 1 and y plus 1, and here both these points are x minus 1 points, x minus 1 x minus 1 y minus 1 and x minus 1 y plus 1 points. Okay, and this one is 8 neighbors of P, combination of this and this. Okay, this one is x plus 1, this one is x plus 1. Okay, x plus 1, x plus 1. This one is y minus y plus 1. This one is y minus 1. Okay. X axis this way, x axis this way, x minus 1. This range is x minus 1. Next topic we will see connectivity. How the pixels are connected. So with the gray levels are used to, means then it represents connectivity. Just a pixel is present at a neighbor, that represents your neighbor of a pixel. But if we are using the gray level values, means then we are used to connect that pixels. Okay, connectivity. Rest all the same concept. For example, if you see 2 pixels P and Q, they are said to be connected if Q should be in the first neighbor of P. For example, you see this one is P and this should be Q. If we can say then this should be the neighbor of this. For example, if center pixel you keep as P and this to be Q. P and Q are said to be connected if Q is one of the 4 neighbors of P. Okay, and this one, next second case, 8 connectivity. Okay, this one is 4 connectivity and this one is 8 connectivity. That is 2 pixels you take P and Q and they are said to be 8 connected if Q is in the set of N8 of P. So already we know N8 of P represents all the 4 nearest neighbors and 4 diagonal neighbors. So altogether this represents the 8 neighbors of a center pixel. Okay, if this one is said to connected with this one or this to be connected with this one, okay, this to be connected with this one means and these pixels should be one of the 8 pixels. And next is M neighbors. Okay, M connectivity, or we can say it is mixed connectivity. That is Q should be in the set of N4 of P. That is, it should be in the neighbors of P and it should be in the set of diagonal of P, and the set of P and Q should not have any common elements. Okay, should not have any common elements. So okay, you see here, yeah, this one is P and this one is Q. Both are said to be connected. If it should be of M neighbor, then it should the common neighbors of this pixel. This what are the common neighbors of this pixel? The neighbors of this one is 1, 0, 1, 1 and this value. Okay, and this value, the pixel is common neighbor 1, 1, 1. So there is no common neighbors to this pixel. Okay, and so they are said to be M connected pixel. Next we will see adjacent. After connectivity we are going to see about adjacency of the pixels. Okay, neighbors and have the same gray level. Okay, then pixels should be neighbors and should have some gray levels connected value, then we can say it is adjacent. Again, it can be 4 adjacent or diagonal adjacent or 8 adjacent or M adjacent. Same concept. Okay, M adjacency, that is mixed adjacency. So here 2 pixels P and Q, they may have the same value, or we can say it is M adjacent. The same thing, P and Q should be 4 adjacent, that is 4 neighbors. First it should be of 4 neighbors. This pixel and this pixel are said to be 4 adjacent only if it is close neighbor. Okay, it should not be the diagonal neighbor, it should be this neighbor. Okay, this is arrangement of pixels. Next, pixels are said to be 8 adjacent. So this is said to be 8 adjacent pixel. The same concept, what is 8 adjacent? Then 4 adjacent, P and Q are 4 adjacent, or P and Q should be diagonally adjacent and do not have any common 4 adjacent neighbors. Okay, they should not have any common 4 neighbors. The same thing what we have discussed in connectivity, the same thing here also. It should be of diagonal neighbor, 8 neighbor. Okay, this one is 8 adjacent, but this one is M adjacent, means they should not have any common neighbor. Okay, the neighbor of this one is 0 and the neighbor of this one is 0. So there should not be any common neighbor. Then only we can connect these 2 pixels. Next is adjacent. A pixel is said to be adjacent only if they are connected. Okay, only if there is connection we can say adjacency. Okay, similarly 2 subsets can also be adjacent if they are connected. Okay, so S1 one subset and S2 is another subset, and S1 and S2 should be 4 connected. There should be a 4 connectivity, or each pixels should have 4 connectivity, and diagonal connected and M connected also. Next we are going to do some operations with the pixels. Okay, that is distance measure. So distance is a function of 2 points P and Q. Okay, P is one point, Q is another point, XY coordinates na, so PQ. So the distance should always be greater than 0. So okay, distance between 2 pixels is positive value and it is same. Okay, PQ, we can write distance between P and Q should be equal to distance between Q and P, and the Euclidean distance can be represented by this formula. As usual, our distance formula we know. Okay, we'll see this one by one. So city block distance, you take x comma y 1 point, and okay, here what is the x value? X value 0, y value 0. Okay, x value, this center value x comma y. Okay, centered at x comma y, and this one is s comma t. Some other point you take s comma t, this value. So this is a city block distance. You have to find the magnitude of value. So that is 0 minus 2 and 0 minus 2. Okay, minus 2, but you have to take the magnitude value, that is 2 plus 2, 4. Okay, that is the city block distance. Next, chessboard distance. You take here d8 of p comma q. Okay, that is here the formula. These formulas you can expect in your exams also. Okay, that is very important. What is city block distance formula? What is Euclidean distance formula? Next, what is chessboard distance formula? Here we have chess square centered, but here diamond centered. Okay, so how will you find the distance between, for example, you consider this point 2. Okay, and the distance between this pixel and this pixel is x minus s. Okay, x is 0 comma 0 means 0 minus 2 and 0 minus 2 modulus value. Okay, 2, 2. Which one is the maximum value? 2. So the distance between this pixel and this pixel is 2. Okay, that is chessboard distance. And we can apply other operators also, arithmetic operators. So arithmetic operation, 2 pixels can be added or average. So where this average is using to reduce the noise. Similarly, subtraction can also be used, and that is used in medical image. And similarly, multiplication can also be used. This is why where we are using multiplication to correct the gray level shading. Somewhere in non-uniformities in illumination or sensor, there we can use this. So anyway, for all the operations, we need to do some arithmetic operations between the pixels. Okay. Similarly, logical operations can also be performed between the 2 pixels P and Q. P and Q, P or Q or operation. Then complement operation can also be applied. So later in future units, future topics, we can discuss where these operations. So many things we are going to discuss: image enhancement, image restoration, all that we are going to discuss. There we can apply all these operators, logical operators. They are applied only to the binary images, but arithmetic operation can be applied to the multi-valued pixels. So what is the binary images? It contains only 2 levels of intensity. One is 0, another one is 1. But multi-valued means the color image, all that. Some logical operations also can be used for masking, feature detection, shape analysis. These are the applications of logical operations where we are using. So one such is mask operation. So what is a mask? It is a matrix. So the mask size may be 3 cross 3 or 5 cross 5, anything. But here we are doing pixel by pixel processing on the entire image. So this mask is going to run over all the pixels of the image. So arithmetic and logical operations are used in the neighborhood oriented. Sometimes we can perform averaging with these pixels. Okay, sometimes we can do inverting operations. So that is mask operation means it's a group of or a matrix of pixels operation. So matrix operation, one example I am telling here. So we can apply this. For example, we have totally 9 pixels, 3 cross 3. So here we can take 1 by 9. That is averaging operation. Okay, averaging of all the operations 3 cross 3, and we are going to replace the average value with the center pixel Z5. Okay, this 5 Z5. In general term, these are the weights we are representing. This average value is nothing but the weight. Okay, and this one is that represents the gray level, and this one is weight into summation 1 to 9. All the pixel 1, 2, 3, 4, 5, 6 like that, and we are going to apply the average value on the Z5 pixel. Okay, center pixel. So mask coefficient we have to here we are selecting averaging. Similarly, we can do any operations. So that is proper selection of the coefficients and application of the mask at each pixel position is very important in image, which makes possible a variety of useful image operations. Okay, that can be done. So one is noise reduction, region thinning, edge detection, all that we can do. Applying a mask at each pixel location in an image is computationally expensive task. So, okay, it takes so many calculations now, but each pixel by pixel. If we have a high pixel in a rate, okay, 1024.724, then we have to do computationally bigger. So like this, we can do so many operations and so many concepts like adjacents, neighbors. So all that are objective type, and you can expect that in your NPTEL exam, online exam, all that such kinds of questions will be asked. Hope the lecture will be useful to you. Thank you.